All right, welcome to this video where Taylor and I are going to discuss the ins and outs of how RToken governance works. We thought it would be a good idea to do this video as just a conversation, a live conversation back and forth between Taylor and I. For context, Taylor and I spent many months on long calls together thinking through the high-level details of the final version of the reserve protocol. But after that point, I went and worked on a whole bunch of other stuff while Taylor and the team actually implemented the protocol in detail. So there's a bunch of stuff about the actual nuts and bolts of how these governance mechanisms work and how the RToken code works that I actually don't understand. And I've been curious about it. And so we thought, okay, we can sort of use my curiosity and like a conversation between Taylor and I, drilling into these details to kind of expose some of the interesting minutia that someone who's curious about RToken governance and possibly innovating in RToken governance would find interesting. So why don't we start off, Taylor, with just like a very basic high-level overview of like how an RToken can be controlled and how RToken, like maybe just how the current RToken governance contract leverages that control to like make updates to an RToken, and then we can go from there. I'll ask you questions after that.
Okay, cool. So I think the thing to start on is actually on the side of the RToken itself. On the RToken side of things, there's actually many contracts, all of which sort of sit under one central security domain. They have a single contract that holds all the relevant addresses that have special permissions over that RToken. And then each of the contracts that sit around this basically look into that central contract to determine, should they allow the caller of a particular transaction to do a thing. So that's how you get sort of this clean, single, abstract object of the RToken system on one side. And then on the other side, we have the governance system. And the governance system is sort of, can actually be quite similar, where there's only like a single point of contact that matters. So that right now, we launched with a essentially fork or small sophistication of Compound Bravo, a very like standard naive token voting contract that Compound Finance initially came up with. There's basically just the very simple set of contracts on that side of a timelock controller and a governance contract, where that governance contract looks into the SDRSR pool and uses the stakes that people have as voting weights that it allows people to vote for particular proposals with.
Okay, cool. And so something I've always wondered about here is like when a governance proposal has been approved and so on, and then there's some package of information that tells like the governor contract that what to do when it's going to somehow via being the owner like execute a transaction and cause some change to the RToken. Like I don't even know how to ask the question, but like what is actually happening in the moment that somebody does a transaction to cause whatever that code is or something to be executed through sort of the owner power? Like what is happening there?
Yeah, gotcha, yeah. So basically there's a queuing of a proposal that has to happen. And I'll ignore the details of like how this exactly manifests in storage and so on, but let's just say you take the details of a proposal, you commit to them ahead of time. The entire governance system has whatever the voting period is to vote on exactly those instructions and nothing else, right? You can't modify the proposal at this point. If something is subtly wrong, you're gonna have to start all over, so on. So this is all in the governance contract side of things. After the stakers vote and the voting period passes, then that proposal is in one of two states. Either it's going to be queuable, okay, so I didn't say executable, notice I said queuable. It's either going to be queuable or it will have been defeated. So if it's defeated, this is sort of the end of its life cycle. it's not going to go any further. If it's queuable, then anybody, so not the person who created the proposal, just anybody, can go up to the governance contract and basically say, take this call data that I initially committed to, 8 days ago, and put that into the time lock, and basically queue the time lock to execute this command after the time lock's delay, 3 days or however long you set it. So this means the time lock is actually the owner of the RToken, not the governance contract, even though conceptually I'll often talk about the governance system as being the owner of the RToken. But specifically, it's the time lock controller, sort of the final contract in the line that could be arbitrarily complicated, but we just happen to have 2 contracts right now.
And so what is the content of that, I think you called it call data, that then then the time lock finally can like read and execute? Is it like Solidity code, or is it some sort of like machine language? Like what is it?
Yeah, so it's machine language. It's bytecode. If to explain this for the lay people here, if you do an ERC20 transfer, right? You're used to working through a particular interface where you go sign a transaction and you hit transfer. So what actually happens in the background? In the background, whatever you're using to craft the transaction actually says, what is the function selector of the function I want to hit? So I actually want to hit a function on a contract called transfer. That is going to be converted to, I forget if it's 4 or 8 bytes. That's embarrassing. I don't remember that right now. I think it's 4. I think it's 4 bytes. 4 bytes of, no, I think it's 8 now. 1, 2, 3, 4, 2, 3. Anyway, a small amount of bytes at the beginning of the call data. Basically, the beginning of the call data is what says, this is the function that we're addressing. After this, it's basically going to pad with the arguments that's going to that function. So, imagine the first 8 bytes here are some crazy, hard to understand function selector, 0x some stuff. The next 32 could be the address it's going to, and the next 32 after that could be the amount that it's going to. So this is what an ERC20 transfer would look like. So the same kind of thing is going on for any old governance transaction that you want to do. So there's a particular function you want to hit. Maybe that's set max trade slippage or set trading delay or something. That gets converted to a function selector. Then if there's arguments for that function, which there's going to be for each of these set so on functions, then it's going to encode the exact value that you want to pass. So this actually, even if you have 20 arguments or whatever, it all just looks like one giant, indecipherable opaque blob, right? You just have this 0x and then this long string of hex data that a human can't really understand unless they've, really trained on this stuff for a while. That is what gets committed to essentially at the beginning of the governance process.
Okay. And so when someone creates a governance proposal, how does the Solidity code get compiled to that machine code?
Gotcha. That actually happens off-chain. So the governance contract is not, interpreting the human command and then producing that bytecode. Instead, you're trusting some sort of off-chain system to figure this out ahead of time. And in fact, actually what they do is they'll do this simulation process where they'll say, let's pretend that I am the time lock controller, okay? And let's pretend that I'm sending this data to the RToken instance. What would happen? And you sort of check ahead of time to make sure that whatever variable you're trying to update actually does get updated, and the transaction doesn't revert, and occasionally some other checks to make sure that the system is continuing to work. And then that gets put into the governance contract, and if that's been done incorrectly, then sort of when this comes out of the time lock controller 8 days later, it's just going to revert. It's just going to fail to work. So this is something that you're doing off-chain and then loading into the governance contract and committing to.
Okay. Okay. And you use the simulation to basically check and see if we call it exactly like this, then we'll go inspect the state of the RToken's configuration after the fact and make sure it is what we thought it was going to be.
Yep.
And so right now, if someone makes a governance proposal, can they enter Solidity code into register and compile it there? Or what tool do they use to actually convert Solidity instructions into bytecode?
Yeah, so the register does have this capability. Sort of the special casing it can do is related to this, like after it simulates, once it simulates running the transaction, it can do some series of checks after the fact to make sure that everything worked correctly. If you're using like an off-the-shelf governance system like Tally, then it's not going to have anything like this. Basically, its simulation is just going to be, does this transaction revert? And if it doesn't, then it's like good to go. It thinks it's correct. The register can have as much, custom functionality as wants to be encoded to be RToken specific checks, right? Things like, what if you do an issuance after this? What happens? Does that work? What if there's a rebalancing auction? Does that still work? You can even, potentially, you can simulate everything potentially after that to make sure that all the functionality remains enabled. Mm-hmm.
Okay. And it also is doing like you would type in Solidity code in register and it does the compilation. Like in that web app, it's able to like compile Solidity to bytecode.
So yes, but it's going to give you a much more usable interface. So basically, you will choose the contract you want to interact with, right? So this is just an address. It can go look at that address and basically understand what is the interface to that address, and then give you, a drop down of here are the 10 functions you can call. And if you've ever done a governance proposal in Tally, it works the same way there. You copy paste some address, maybe you took that from Etherscan or something. It will usually be able to just automatically fetch what's called the ABI, but just like the set of functions you could call and their arguments. And then you make some selection from that. You fill in the actual value of the parameters. And then at that point, the thing you're talking about happens. So then the web app would actually convert that to bytecode at that point. And then you'd send that bytecode with your transaction.
Okay. And so like if someone like did like a man in the middle when you were loading that web page, that could be a problem. Like you really are trusting like the JavaScript that's running in your browser to do the compilation correctly.
Yes.
It's a little scary.
I was going to mention that, but you brought it up. Or rather, sorry, I skipped over mentioning that, but you brought it up anyway. Yes.
I guess the simulation step helps. Like you'd have to like really anticipate what someone was going to type in and somehow change the simulation logic as well to show them exactly.
You can lie about the simulation outcome as well, right?
Right. Huh. That's interesting. So like in the limit, like the more valuable these things get, like you really want like some sort of verified software where you're running the right software to do that compilation.
I would not look there as the line of defense. So what you said is true. You want the software should be trusted and you should know you're not interacting with malicious web page. Okay. That said, the correct line of defense is going to be verifying, because remember, you commit to the bytecode at the beginning, right? Mm-hmm. You send your transaction with, here's my bytecode. Maybe your bytecode is malicious and you don't know that, right? The right thing to do is actually to have a process for other people to run the simulations themselves on the bytecode you've committed to and figure out, even though I trust Taylor and I don't think he did a malicious thing. Maybe he was interacting with a website that tricked him into doing a malicious thing, right?
Right. That's a good point. And that's actually an interesting idea for a relevant community norm in basically all blockchain governance, which is like, even if you trust the person who announced this, you should be careful and skeptical every time. Like we need people checking because their tools could have deceived them. Where obviously if everyone just goes and uses register to check it, like if everyone's using the same tool to check it, then that doesn't necessarily help. Okay, so it really seems like the line of defense is running the simulation and checking the outcome, which the person making the proposal can do with separate software and other people can also do with separate software. And so, if there's enough checking on that level, then you're probably okay. Okay, that makes sense. So then one other question I have here is when, abstracting away from thinking about Alexios in particular, when whatever governance contract, whether it's a timelock or whatever other module within the governance contract system is calling a function within the RToken, is there like only one general function that it has the permission to call that allows it to make any update, or are there like tons of different functions in that available interface, and if you're the owner, you can call any of those and nobody other than the owner can call any of those? There's like several?
Yeah, great question. Yeah. So basically there's something like 12 individual precise functions you can call to change some particular variable. And then in addition to those 12, there's also the upgrade to function. So I'll skip the details of proxies, but basically there's a way to change the code that is executed in a particular contract, let's say address to be more correct, at a particular address. And this is a power that governance controls, and basically it executes it via calling a function called upgrade to. And this actually works the exact same way of like the whole system I just laid out of, well, there's like a function selector and then some arguments, and basically the proposer at the very beginning, receives this call data from the web app that they interacted with and puts this into governance and people vote on it. Basically, the process for upgrading an individual contract is actually the same process as calling one of these very precise functions that allows you to just change a specific knob in the RToken.
And so the upgrade to function basically allows you to say, like, let's just say, like one of the contracts is like the revenue trader, just picking one at random. It allows you to basically say, forget about all the code that you would have run for the revenue trader before. Instead, here's all the new code, which could just be one tiny change from the old code, or it could be completely different code. And you can do this for any of the contracts within the protocol. So if the people vote, then they can say, like, we're replacing that whole logic with this new logic. And you can batch updates to like 3 out of the 9 or whatever contracts it is all at once. If there's some logic change where you need to make a change here and here, that can all be part of one governance proposal, so it would all be executed or not atomically in one transaction, right?
Yes, exactly. Yep.
Okay. And so, sorry, you said you wanted to skip over the detail of proxies, but let's talk about it for just a minute. So,
yeah, sure, happy to.
So does that mean that, okay, so like, maybe let's start with like a simple practical question. If you do that process where you change, well, no, why don't you explain what proxies are, and then I have like a practical question on top of that.
Yeah, sure. So there's basically 2 things to know about in proxies. You have your proxies and what's called the implementation. And basically there's 2 things that you kind of care about in a particular smart contract address, which is there's the state associated with it. These are things like, who has what balance and so on. And then there's the code that should be executed. And these are actually different. And basically what a proxy and implementation does is it actually like properly decouples these so that you have one contract where you put all your state in all the time. You put no state in the implementation contract ever. In fact, it's like an anti-pattern. It's like a dangerous thing to do. And then on the implementation contract side, you don't have any state and you have all the implementation logic there. Now, you don't actually succeed in having no logic on the proxy side. You actually need some very basic logic that basically says, if I receive a call, I forward this, or rather, I execute the code in the implementation contract from my own context. So there's like a small amount of code necessary to have that logic. It's sort of meta in a way. So that's the proxy and implementation. There's different ways to do proxies, but there's basically one best way that has been discovered. The other ones all crumbled and had attacks in the past.
Okay. Reassuring. So then when you are replacing the code, you actually are replacing the implementation contract. So now there's like an abandoned implementation contract that's just there, but no one ever will call it because it's not referred to anymore. You actually are changing the address that the proxy contract points to for the implementation contract. Okay.
Yes. And that makes sense. Yeah. And then with that model, you can see how it ends up looking the same thing as like set max trade slippage, right? It's like upgrade to, here's an address, same kind of thing.
Got it. Okay. And so then if you're looking at the system of contracts on, say, Etherscan and trying to like look at the contract code or check the verified contract code for like a new implementation contract that's been swapped out, you would be able to trace and see, okay, the proxy contract now refers to this new address. I'm going to go look at that contract address and then check its verified code on Etherscan, and that's how you'd be able to tell like what the new code would be after an update.
Yep, exactly. And Etherscan has some special case logic here, where it'll actually look for you at the implementation contract and load its ABI, the interface you need to communicate with that address, if you were going to, as a legit interface for using to address the proxy, right? And this
because
is, people have probably seen
particular proxy design pattern or something.
Exactly. They basically special cased exactly that proxy pattern. But if you ever see if you go to the contract tab on Etherscan, and then you'll often see like code, read contract, write contract. That's there for every single contract. For a proxy contract, you'll see 2 additional tabs, write as proxy and read as proxy. And basically, you would use those to address the proxy using the ABI of the implementation. So anyway, this is kind of complicated, but if you're listening to this and you're kind of overwhelmed, I would just say always use the read as proxy and write as proxy tabs. That's like the real interface. Yeah.
Cool. Okay. Awesome. Okay, that makes sense. So then basically then to kind of step up a level and summarize, whichever account, like could be an externally owned account or a smart contract, is designated the owner, can call a bunch of those, I think you said 9 or so functions that like set particular variables. And it can also call what was the general upgrade function called?
Upgrade to,
which basically you can use to replace any of the implementation contracts with new contracts. So that allows you to basically swap out the major modules, which include, the broker and the revenue trader and even like the RToken itself, right? Like, so you could change like the ERC20 transfer logic of an RToken by changing the implementation contract.
So you could add transfer fees or something. Yes.
Yeah, like make it snapshotable or other things like that.
Yep.
Okay. Cool. And so let's think about where best to go from here. So, well, let's talk a little bit about the other kind of edge case governance powers that aren't just the ownership address, right? The guardian and others. Why don't you summarize those?
Yeah, sure. So the RToken system instance, as we already talked about, has this owner address. That owner address is set to the address, one of the important addresses from the governance system. There's 3 really, as we pull apart the freezers. There's 3 other roles that are also relevant. So there's a pauser, a short freezer, and a long freezer. So first off, the difference between pausing and freezing. Pausing stops trading and issuance. So when I say trading, what do I mean? I just mean any time where the backing for an RToken moves over a contract boundary. That's too formal a definition. Anytime the backing capital is swapped out, right? And pausing stops that and issuance. And the reason for that is you can end up in some situations where you really need to pause issuance, or else someone could inject bad capital into the system. This is basically like causing there to be more bad debt, which you don't want. So that is on the pausing side. And you might think, okay, well, if that's pausing, what is freezing? Freezing is everything that I just said, plus the halting of redemption as well. But we kind of hold redemption. Redemption is like sacrosanct. It is special in a particular way, right? Because redemption is the exit. And sort of in the same way that like in a DAO, you might want the ability to rage quit always in a way that preserves your own sort of pro rata share of the thing. That is also what the RToken holders do when they redeem, right? They're basically saying, hey, all this backing sitting over there, I want my pro rata share of it because I'm going to exit. So turning this off for any period of time is like a really big deal, right? I mean, honestly, if we knew the code was fully correct right? And this is very hard. It's very hard to get into that state going from 0. You only get there after you have evidence from reality over many years, basically. But if the code were perfectly correct, you just wouldn't have this available ever, right? You would say redemption is full stop, always available. So sort of the next best thing you can do is you could have some sort of temporary or finite time that redemption can be turned off. And this is what freezing is. So freezing is always temporary. It always thaws by itself. And the question is just, on what timeline does it thaw? So this is how we get the difference between the short freezer and the long freezer. The short freezer is an address that can be trusted to freeze for, I mean, I don't prescribe a particular value. It depends how you set up the RToken, but I think the default value is like 3 days if you don't change it in the UI. So a short freezer can do a single freeze at 3-day length, and there can be multiple short freezers, right? A long freezer, so again, value of the long freeze can be set to RToken.
So you can specify any number of addresses to have that freezing power?
Yeah, that's correct.
Okay.
Yep. So, that there you have one shot or one use of it. You could have multiple uses by assigning it to multiple addresses that are controlled by the same individual, right? That's one option there.
And so for the one shot, you're saying like when you give an address the ability to freeze, it can use that ability once and then it can't use that ability again like in 3 more days or something. So if you want your governance ecosystem to have multiple shots, you have to assign that to multiple addresses to achieve that.
Yep, exactly. And governance would be the one to re-grant the freezer ability.
Okay. Are both those properties true for the pauser as well? Or like you can have multiple pausers? Okay.
Yeah, so, you can have multiple pausers, correct. But pausing does not go away. It's not one shot. You just have the pausing permission. And that's because pausing doesn't turn off on its own, right? Pausing actually requires someone to come forward and unpause the system.
Can the pauser unpause, or does the owner need to unpause? Okay, so the pauser can pause and unpause
pauser or governance.
On whatever timeline. And you can have any number of pauser addresses specified.
Mm-hmm.
Okay.
Yep. Okay, so where are we on long freezer? Yeah, so long freezer, pretty similar to short freezer, except 6 uses instead of 1, right? And this is actually not tunable. This is not a governance param. You could obviously change it by the sort of upgrade 2 implementation replacements that we were talking about, but it's a bit more fixed in the code than the value of a particular governance parameter. Anyway, 6 uses for the long freezer. You can set the long freeze timeline to whatever you want. I think the default in the register is a week. That ends up being one address can do 6 weeks end to end of freezing, which is honestly quite a lot. So maybe use a smaller long freeze length. And again, this can go to any number of addresses. And it thaws on its own, right?
Okay. So we have the pauser, short freezer, the long freezer, and then also the guardian. How does the guardian work?
Also the guardian. So the guardian is actually, let's start with, you can have any number of guardians. So actually all the guardian is a canceller in the timelock controller. So after a proposal has made it through the governance process, it's in that final 3-day delay before execution. The call data is sitting there in the timelock controller, about to go to the RToken system. There can be any number of addresses that can basically step in and veto that and say, look, I know this call data ended up here somehow, but I'm going to step in and say, no, this cannot be executed. This cannot go to the RToken instance.
Okay, so that's actually part of Alexios. That's actually not part of the RToken contract itself.
Exactly. Because as you may have noticed, this is sitting entirely outside the RToken, right? From the RToken's perspective, it's just, do I receive a call from the owner or do I not?
Okay, but the pauser, short freezer, and long freezer, those are within the RToken contracts.
Correct. Yes, they are. Yep. So that's a difference here between Guardian and these particular narrow roles.
Okay, that makes sense. Okay, great. So, okay, let me just think about what I'm curious about now. Okay, so let's go in the direction of talking about limiting governance powers. So let me start off with like a simple point, a simple statement, and then we'll talk about some of the more complicated parts. So obviously, on like in a sort of blunt way, any of these, well, okay, first off, the pauser, short freezer, and long freezer sets of addresses are themselves configurable by the owner address, right? The owner,
Correct.
whoever owns the owner account. Okay, so basically, when you deploy an RToken, you get to initially set them, and then whatever your governing contract is, it can update them over time if it is able to, right? If its internal logic allows it to. You could then have any of those set to the 0 address, or just not specify any addresses. Do you just not specify any? Yeah. So
yeah, these end up being equivalent actually, but
they're
I'll
equivalent.
ignore.
Yeah,
we can skip over that.
Yeah. Okay. Okay. So, but in any case, you don't have to give anyone those powers. It's just an option.
That's right.
You could have it be that no one's able to pause, no one's able to short freeze, or no one's able to long freeze. Noting that the owner address could then reverse that decision if it has general ability to execute any change. And so, so if you wanted to commit to forever not having, short freezing or long freezing, you now need whatever contract is at the owner address to never be able to make that change. And so then that gets to kind of a meta point, which is the owner account can change who is the owner account itself, right?
Exactly.
So if you have a governance contract or a multisig or your own Ethereum address or whatever, even if you had a contract that limited its own abilities to change certain variables in order to try to credibly promise, look, this thing will never change, it'll always be this way. If that owner contract is able to replace itself with something else that has more general powers, and it hasn't given up its own ability to do that replacement, then everyone has to keep in mind that it always could do that and always could then go change anything that the RToken allows to be changed, which, as we talked about with changing the implementation contracts, you can swap out these modules, you can change all sorts of stuff. And so that's actually a pretty big deal because, if you think about what an RToken is and what it might be like if you have some that are worth hundreds of billions of dollars or more, like you potentially want to get to the point where you lock down more and more variables and there's like things that change, the basket evolves, but the incentive to come attack gets bigger and bigger. And so it might be desirable to actually have less and less control, even if that means that some RTokens could get very big and be a little bit too ossified and need to abandon them and switch to a different RToken, an entirely new RToken. That might be a very smart trade-off because you get that sort of certainty that certain things can't go wrong. So you can see that you could create a governance contract that is made to be the owner, which limits its own ability to change certain parameters, right? Like, I'm not sure exactly how that logic would work, but like you could somehow program it so that like certain, it's able to call certain functions, but not other functions, for instance. Or maybe it can call certain functions, but only set the value to be like certain preset things, which that reminds me of like the bounds on things in the RToken contracts. Let's talk about that in a minute.
Okay.
And so, and then if you wanted to be able to make, sort of commit forever to only being able to make those changes, one possibility would be to make it so that that owner, the owner contract can't replace itself because its internal logic doesn't allow it to call the function that would be necessary to replace itself. And so you are kind of deciding like, okay, this is the way that this will be governed forever. We're giving up the ability to change our governance paradigm, even if we all collectively wanted to vote to, no longer be a democracy and instead work in this other way. We're just saying like, nope, can't do that. We would have to do that by basically abandoning this RToken and moving on to a new one. But there is, I think, an interesting middle ground, which I expect to be explored, which is saying, okay, you can call that function to replace governance, but it has to go through this special routine that has like a 6-month delay baked in, or some very long delay.
Mm-hmm.
So basically, you could have very limited ability to make changes, but then maybe you need like a super majority, and there's like a 6-month delay, or like whatever things where basically that would mean that if you really needed to in some sort of unexpected edge case emergency where all the collateral has for some weird reason gotten locked in the contract and you need to whatever, like or just if if your political philosophy is like, no, we should be able to change our form of governance if we're all on board with that, but obviously we also want to give people sort of certainty that it's not going to happen by surprise. Maybe it's like 1-year delay or something. So basically there's a whole interesting range of possibilities to play with in limiting governance powers, and then having sort of escape hatches or whatever, but with whatever properties that are like hopefully very easy to understand and very conservative, so that you can still make those changes at some point in the future. Did anything I say there not quite add up or make sense, or anything you want to add to that?
No. That is totally correct. So just to say really quickly for people, it's like you could have the governance contract allow you to change these particular parameters, the small knobs, what is the max trade slippage, what is the trading delay, so on, with one timeline, and it could make general calls on some other timeline, general calls being these like upgrade calls, and then you could special case the change owner even yet again to be a third group, right? And this could be something like 6 months, like what you said. The one thing I want to add to this, though, is there are other ways to achieve this similar ends. So 2 ways you could do this. I'll start on the less good way and then end on the better way. So on the less good way, you could remove general upgradability of the RToken contracts. And you can actually do that on a per contract basis, right? So it could be something like, the RToken code has really shown itself over time to be pretty solid. We have a solid Lindy going on there, and we think it's safe to make that immutable, but maybe the same is not true of the staking pool, for example, right? So the STRSR contract maybe still has upgradability enabled. So this is actually binding your hand much more strongly as governance. And I guess this doesn't really weigh into the how would governance change itself question, but in terms of constraining the RToken behavior, you could use this so that governance can actually convincingly tie its hands. Right?
And what's the mechanism there for giving up upgradability of a single contract? Would you have to decide that at deployment, or is that something you can do as the owner?
You can do as the owner.
Oh,
yes, that's correct.
Interesting.
Yeah.
Okay, so the owner can basically call a function to say, disable upgradability of the broker, and then for that RToken, it just never can be changed again.
Yep. And I'll skip over the proxy implementation interaction there because it's actually complicated. But yes, this can be done.
That's very cool.
Okay, and then should we do the second way here? So there's a second way you can tie your hands, that it's sort of sitting between these two. So if on one end, the thing I just said is sort of, fully tying hands of governance because it's actually the RToken contracts, which are no longer upgradable. And then, on one side we have, well, maybe there's just a longer timeline to upgrade these contracts. That's implemented on the governance side of things. In the middle, you actually have more space to find designs like, so this is why I sort of mentioned your governance system can be arbitrarily complicated, right? We talked about there just being 2 contracts right now, timelock controller and governance. You could have more, right? You could think of the thing as what we think of as governance and where the token voting happens, right? You can think of that as being input to some more immutable contract, right? So, just like we're living in a paradigm right now where the governance contract prepares something and then gives it to the timelock, which ultimately delivers it, right? You could have an intermediate contract, right? So you could have this intermediate contract between the time lock and governance, where governance says this intermediate contract, here's the call I want to do. And basically that contract, which is not upgradable, okay, right, basically has some checks built in that are like, I do not allow calls of this particular form. So basically this is governance. Basically, it can upgrade itself, the governance contract, which is sort of 2 degrees out, right, from the relevant ownership. Time lock controller is owning. There's intermediate contract that's sort of filtering the calls. That one is not upgradable. And then most furthest out, the governance contract where token voting is happening. And then you can sort of imagining this being n layers deep, actually, because, you know, I said the intermediate contract's immutable, right? So how do you, now I want to lock down more things, right? But we just said that was immutable. How does this work? You can just have more of these pass-through contracts, right? Each one individually immutable. And I'm sure there are other designs for this, but this is just like the one that jumped out right here as like, look, there are ways for governance to bind its hands in a narrow way that is truly immutable.
Okay. And so like for the process that, for like the code that would be running in this example in that immutable contract, or it could be you have code like this in an upgradable governance contract, like how is it that it somehow checks that machine code in a way that makes any sense to know, like, oh, this is setting whatever variable to a value that's too high, therefore, like, do you have to be some sort of like AI to figure out how to write the code that would run those checks? Like, how does that even work?
Yeah, that's a great question. Let me think. So the limits on particular parameters, that one's pretty tricky, actually, because if the thing that you're getting, the atom you have, is just the call data, you can deserialize that. Okay, actually, this is just fine. Yeah. Okay, so if you know the ABI, the interface of the RToken system contract that you're interacting with, and you have the call data, you can work backwards there deterministically to go to sort of the human readable version of the values.
I see. So basically, it would effectively like decompile and then check the value that the human had put in order to compile to the bytecode or whatever.
Yeah, I would definitely want to like confirm that this is not gameable in some way, and it's a one-to-one mapping like I currently think it is. But like, yeah, you would do something like that. If that weren't possible, right, you would just special case. You'd have some functions that know what variable they're changing in the RToken system instance, right? And then there you could have the sort of range constraints set.
I see.
And then the one other thing I wanted to hit on here was going back to the function selector. So these 4-byte hashes of the function name that's being called, right? So this is what you could use to forbid general calls. So, you know, you could say, I do not pass along any call data whose first 4 bytes are in some set, right? Where these set are the functions that cannot be called anymore. And if you still have general upgradability in the RToken system contracts, then this is not actually a defense, because they can be upgraded to change the name of the function and so on. Yeah, you could use a mechanism like that. Yeah, I haven't thought super deeply about the entire space here, to be honest. But there's definitely quite a few things you can do. We've already hit on a few of them.
Yep. Okay, cool. And then I feel the need to briefly mention the fact that in the RToken contracts themselves, you can have hard-coded limits on variables. And I think, Taylor, you've explained this to me in the past as not really intended to be used for limiting the ranges for the sake of governance, more intended to be used so that if someone like is on the wrong order of magnitude or something, that gets caught rather than pushed through. In theory, you could have them be narrower ranges for the sake of predictability, although that wasn't necessarily the intended use case. How do those get set? So if you're deploying an RToken, do you specify those up front, or is it just literally in the code of the contracts such that you would have to like not use register to deploy and go like do some sort of more custom thing to change the code of the contracts, or like how does that work?
Yeah, so the ranges themselves, right?
Yeah.
Yeah, so the ranges themselves are actually in the bytecode of the contracts. So if you are deploying a new RToken instance, you are using a particular contract as the implementation, you would inherit whatever range constraints come along with that.
Yep.
So I just wanted to flag here, though, that if you have general upgradability, so that the reason why I would say that thing to you of, well, it's not really here to prevent full stop from particular permutations of variables, because you can't actually when you have the general upgradability.
That makes
right?
sense.
So that's why it's there, just to, like, you didn't realize this number needed to have 18 more decimals than 18 more zeros than you were expecting or something. Kind of thing.
Got it. So you'd have to, like, but if you wanted to, in theory, you could, after having deployed the RToken, you could replace the implementation contract to set a range and then give up the ability to change that implementation contract. And then you would have that fixed range on that variable forever.
Yep, exactly.
Okay. Cool. Yeah, it's so cool to just, like, understand the details of these knobs. I really do feel like this is kind of like the basic 101 information that someone needs if they're going to start brainstorming for different types of governance approaches. Why don't we talk for a few minutes about different possible governance directions? And I'll just note here that, like, there is a team within Reserve that thinks about governance R&D. Taylor and I sit in on meetings from time to time. We're not actually on that team, so there's, like, a bunch of people with, like, more rich detail on these ideas. But just to, like, point out a few things as food for thought for anyone watching this video who might think about different possibilities themselves. So one interesting direction is, in the broadest sense, is basically, I'm trying to figure out what the right term is. It's sort of like, programmatic or like maybe like Oracle-driven governance, where at least some part of the governance actions that the governance contract or set of contracts end up executing are basically pre-baked function calls that basically get their variables populated and the ability to call them in the first place in response to, for example, Oracle price feeds or Oracle data feeds of any type. It could be, and so, like, here's a sketch example of this that will make it make more sense. You could have an RToken where it has a predefined, say, whitelist of collateral, like possible collateral assets, that gets voted in via whatever mechanism. And then maybe on, like, a bi-weekly basis, there could be a rebalancing function that can be called if there's, like, enough change to whatever parameters your rebalancing function cares about. And so one thing it might care about is, like, the APY for different collateral assets in whatever the lending environment is. Maybe one asset was good to include 2 weeks ago, but now its APY has gone down to 0 because people have stopped using it for whatever reason. And so you could have a system that allows for anyone to come call a function to cause a rebalance of that basket just based on that Oracle data feed without needing to cast a vote or without even being able to cast a vote. Like, you could just decide this is not something we vote on, we just do this formulaic thing that's predetermined based on those Oracle data feeds, where obviously Oracle's a little scary. You need to make sure that you're not relying on an Oracle that could be manipulated in a way that'd be problematic. One interesting direction that I'm curious about, actually, Taylor, I meant to ask you about this, so maybe now's a good time to talk about it. Like, if you wanted to get, for instance, like APY or TVL information about a particular collateral asset, those seem like the sorts of things that you could potentially reach out to other contracts and get directly on chain without needing to rely on off-chain oracles. But is that doable in practice, or is there something dangerous about that? Like, because you're assuming that those contracts won't change, or certain things like do you think that there are good opportunities to rely on data that is already on chain, or Or is that not really a thing in practice because everything is shifting around, and so you always kind of want to have the human judgment involved of like an Oracle off-chain data feed?
Yeah, so the point you raised of you really want the contract that you're building on top of to be relatively fixed and immutable at this point. So this like Oracle source, right? You know, one type of pricing Oracle is a AMM that provides a TWAP, a time-weighted average price, right? If those AMM pools are all truly immutable, which, you know, the vast majority of AMM pools are, then you could be pretty confident building on this as one of your input sources for data, right? Now, let me make this worse. So on the Chainlink, right? Actually, Chainlink is something more of the form that you're trusting their reputation that's on the hook, right? They could actually change the data that's going into that Oracle, right? And you are trusting essentially their reputation and the fact that if they did do something, if they did report bad data, that would cost them more in future revenue streams than they could steal in this particular moment, right? And then it gets a little worse once you go cross-chain even. And actually you can view the Chainlink case as something like a cross-chain problem. But basically, and I raise this because I've been talking a little bit to the governance team about this, because they wanted to know things like, or rather here, let me put it this way, you know, they'd have a spreadsheet that they've written up where it's like, look, I had these APYs from Aave on these various chains, right? And other DeFi protocols. The point is that it was spread across different chains, right? If you want that data, that is actually going to be extremely dangerous to get, because you have lost your single security domain of Ethereum, right? Now, an L2 is probably going to be okay, actually. Yeah, an L2 is probably going to be okay. You can actually read from an L2 in such a way that that data you're reading out is about as reliable as it would be if it were just on Ethereum L1. But as soon as we switch to a sidechain model, right, and we're just talking about, I don't know, Cardano or something, some other chain, some other smart chain, and you want to know what is the APY in some market there, that is actually like truly a dangerous piece of information to try to get, or dangerous. It's truly difficult to get that to a high degree, because basically you are solving the fundamental security problem that blockchains are trying to solve in the first place. In order to solve that, in order to get the same degree of assurance that you would need to if that market were located on ETH L1. So that was pretty long-winded, but the point I didn't want to make there was just that if the data is from L1 primarily and it's on immutable contracts, then pretty good. You can just read that data. Possibly the munging of it or the aggregation of it can be something that someone has to pay for, right? But you can make that payment at least permissionless, so anyone can do it. And then you move to the like centralized, or there's some sort of upgradability component. That's sort of the middle of the road. And then the very, very worst thing would be this thing's on an entirely different chain in the first place. How do we even verify the data that we're reading is correct?
Yep. Awesome. Okay. And then, and we can sort of think of that category overall as like kind of like programmatic, data-driven governance or something like that. And I think that whole area is very interesting to explore because, there might be, especially for managing the basket itself, interesting question whether this would apply to any of the parameters other than the basket itself, maybe at least the emergency collateral assets. It's just very intriguing to think about, like, are there systems that are both less work for the, community of governors? They just don't have to, like, read about things and weigh in on a regular basis to make those changes because it's all predetermined, and also then more predictable for the RToken holders. They don't have to rely on, whatever the community of token voters are for those types of decisions. Where again, you can layer these mechanisms together. You could have a whitelisting process that's maybe very slow and conservative, but does rely on human judgment, where maybe, something is voted on and it can't then be added to the whitelist for like 3 months or 6 months, or even just 1 month, like a long period of time, where RToken holders then have plenty of time to decide and sort of consent, yes, I want to go along with the world where this is a possible collateral asset I could end up being exposed to, and then have like a much more nimble, like weekly or bi-weekly rebalancing that's trading around within the whitelist. So that's a pretty cool direction. And then one other direction to call out, and Taylor, I don't know if you have further ones to mention, but like is just like, for token, for basically including human judgment, you don't have to do, one token, one vote, right? You can mess around with any different kind of voting system. You could have a system that where people can, through whatever trusted mechanism or like semi-trustless network, verify that this address corresponds to one human, with like the proof of humanity approach, or there's, new approaches being tried now with like a zero knowledge proof that checks against, you can have like a, your passport NFC or whatever it is, maybe it's an RFID, I don't know what it is, somehow read, and then have like a zero knowledge proof that's like, oh, you're a human and you're from this country, but we don't know anything else about you. Or maybe just you're a unique human within the system or something like that, according to the government that signed your passport data or whatever. Anyway, the point is that, you could have like individual humans voting. You could have special roles, of course. You could appoint, a particular person who's the expert in charge of this one particular aspect of the governance, or you could have, anyone who has a certain NFT type is able to govern this thing, or, it's like, it's programmable. Like you can just have any degree of complexity of different types of roles and different types of process and so on for aggregating human judgment and human preferences and so on. And then, so yeah, that's a whole like area to explore. And then do we have other directions to point out? I guess there's market-based, right? So you could imagine, this is sort of a special case of the data feed in a way, but one interesting possible case within the data feed category is like, you could have a prediction market, or you could have some other kind of on-chain market that is then a way to measure some information about people's belief in the safety of certain protocol assets. If everyone's suddenly betting against a certain protocol or a certain underlying stablecoin or something in the prediction markets, then maybe that enables the governance contract to quickly trade out of that asset. And then I guess last thing to mention here is, we tend to talk about staked RSR holders participating in the governance process, but you obviously, another universe of stakeholders you have is the RToken holders themselves. You could allow RToken holders themselves to have or delegate governance power and execute that in various different ways. So yeah, anyway, it's just some food for thought. Like, the big picture point here is like, it's an enormous universe of possibilities with how modularly the system was designed. It's cool that it allows you to have it completely upgradable, essentially, and change sort of almost everything, or to give up more and more of that power and have something that's more and more, less and less upgradable. You could have an RToken that's not changeable at all. You just set the owner address and all these other addresses to the zero address, or not specify them. I still don't quite understand the nuance there, but you just make it so that it can't be changed at all, and then it's just a fixed thing. People can use it with 100% certainty, and you just have to redeem and switch to something else if you at some point don't like the basket. You could have something that is 100% fixed except for data feed driven rebalancing. So you could have sort of a fixed whitelist, only rebalance within that whitelist, etc. So there are a few different, spectra to kind of explore there, and lots of different possibilities. And we made it this way precisely because, we've been complaining for years that we don't feel good about the state of blockchain governance. Most people who think deeply about it don't feel good about it because it's such a tricky thing and there's so much work to do. And we just felt that it would be a better move, thinking about the next 20 or 30 or 40 years, to make it so that it's an open space for many people to explore and for different models to sort of compete against one another in the market and try to get to the best solution that way, rather than us, much as our team likes to try to think everything through in advance and figure out like the way to do things. At a certain point, we're like, that's not the right way to approach this particular challenge. So, as we've mentioned in this conversation, like we do have a few people on our team who are thinking about governance, but I wouldn't even say it's really our main focus right now. If you look at like the total effort that we put in, our engineers are putting a lot more effort into like building collateral plugins and other things like that. We don't expect to solve governance ourselves. We want to try to contribute to it, but we expect it to be, in the way that like the creators of Ethereum didn't expect to like create all of the best Ethereum apps. Obviously we don't expect to create all the best RTokens. We're anticipating others doing that. And similarly on the level of governance design, if RTokens gain in popularity, we think that there will then be incentives to think hard about RToken governance. And it would be so cool if it ends up being a really rich governance R&D playground that then ends up generating design patterns that can be used elsewhere in the smart contract ecosystem. And a lot of this stuff does seem to apply. If something works in one case, it's like, oh, how do we do that in this other case? We were inspired by Uniswap's, factory contract and permissionless deployment of trading pools to think about, well, what if we did that with basket-backed stablecoins? And so, yeah, I'll be really pleased if those incentives and market competition and so on solves it for Reserve, but then also if that's able to contribute to the overall phenomenon. So I think, Taylor, is there anything else you want to throw in before we wrap up, or?
I'll just throw in real quickly that so much of the design space is not available until there is some sort of identity system. And this is, why you mentioned proof of humanity. But, this could come different ways. Governments could decide to use asymmetric key pairs instead of social security numbers, right? And then they could control the recovery system. Some people might think this is terrible, but anyway. And you could just use that key pair as sort of your, to address individuals. So I just think there's like a bunch of innovation that is it's waiting, it's sort of like dammed up and it all wants to come out, but we just need some reliable identity system first. And then we can play with quadratic voting, democracy, which is, it doesn't matter how many tokens you have, you get one vote no matter what, and so on. There's a much larger design space here than people are aware of.
Yep, totally. Cool. All right. Well, if you've watched to here, you are obviously some sort of governance geek, and I invite you to come hang out with the Reserve governance team, talk to them in our Discord. They do a lot of their discussions just hanging out with each other in video calls, so you might not see a lot of chatter in Discord, but if you come and share your ideas and ask questions and so on, they'll find you and engage you there. Taylor and I are on that Discord too. Feel free to tag us and ask us any questions about something that we talked about here that you didn't understand, or share your ideas with us. It's my hope that this video will inspire a handful of people to kind of dive in with us and start thinking about it. I guess the last thing I'll mention is that we're open to bringing more people onto working on that governance R&D effort within our team. So if you'd be a good fit for the team and wanted to work on that, we're happy to talk about that as well. And I think that does it. So thank you very much for tuning in. Make sure to like and subscribe. No, I'm just kidding. Thanks, Taylor, for this conversation. I learned a lot too. I enjoyed it.
Happy to.
All right. Ciao.
Great. See ya.